A signal just reached Earth after traveling for almost an entire day from something we launched in the 1970s. And the craziest part is that it's still talking to us from interstellar space. Okay guys, welcome back to my long form videos. Today we're going to be talking about where that signal came from. Voyager 1. Voyager 1 is the farthest human-made object ever built. It was launched on September 5th, 1977 by NASA during a rare planetary alignment that only happens about once every 176 years. This alignment meant something pretty incredible, right? With the right trajectory, a spacecraft could visit multiple outer planets using gravity assists, essentially stealing a little bit of momentum from each planet to slingshot Voyager 1 forward. Voyager 1's primary mission was to explore the outer solar system, especially Jupiter and Saturn. And it pretty much delivered. At Jupiter, it revealed active volcanoes on Io, the first ever seen outside of Earth. And at Saturn, it captured pretty detailed images of rings and discovered new moons and structures we didn't even know existed. But here's the thing, Voyager wasn't just a science mission, it was also kind of a message in a bottle. Attached to it is the Golden Record, which is a gold-plated disc containing sounds, music, images, and greetings from Earth, designed in a case that any intelligent life ever finds it. After Saturn, Voyager 1's trajectory took it out of the plane of the solar system, giving us the first ever family portrait of our entire planetary system, including the famous pale blue dot image of Earth. And then it just kept going. NASA essentially extended the mission, turning Voyager 1 into something much bigger, a probe to study the boundary between the solar system and interstellar space. In 2012, it officially crossed the heliopause, which is the edge where the sun's influence ends, and became the first human-made object to do so and to enter interstellar space. Now here's where things get really interesting. I mean, Voyager is so far away that its signals travel at the speed of light, and it still takes about 23 hours to reach Earth. That means every time we hear from Voyager, we're literally hearing from the past, from nearly a day ago. But the signal itself is unbelievably weak, right? By the time it reaches Earth, it's something on the scale of 10 to the negative 16 watts, which is less energy than a single snowflake hitting the ground. So how do we even detect such a small signal from Voyager 1 when there's hundreds of millions of thousands of watts coming from the sun and from cosmic rays and totally different things that aren't Voyager 1? The answer is we use massive radio antennas on Earth, like NASA's Deep Space Network, and apply signal processing techniques to pull Voyager's signal out of the noise. This involves correcting for Doppler shift because both Earth and Voyager are moving relative to each other, and even tiny velocity changes matter at these distances. Voyager is now so far away that its position is measured in light time, not distance. It's approaching about 1 light day away. Light itself takes a full day to get there. One of the most common examples of light time is a light year, which is how long it takes light to travel a year. So it is measured in distance in a way, but that distance is not the distance we like to use, like astronomical units or anything of that sort. It's light time. And at that scale, the solar system stops feeling like a place and starts feeling like a region in space-time. Even more interesting is that Voyager is moving through the interstellar medium, which is a thin soup of charged particles and magnetic fields. It's helping us measure things like the density of interstellar plasma, magnetic field strength beyond the sun's influence, and even how the solar system interacts with the rest of the galaxy. This is data that we literally could not get any other way other than sending a probe out into space. Now, recently, astronomers, even amateur astronomers, have successfully detected Voyager 1's signal again. That alone, first of all, is insane based on what I've been saying, right? It's a really difficult process, and you do have to cut out a lot of noise. Because Voyager is nearly 50 years old and running on pretty outdated hardware, powered by a slowly dying radioisotope generator, it makes it even more impressive. Every year, Voyager loses a little more power, and NASA has already had to shut down instruments just to keep the transmitter alive, and yet it's still talking. I mean, think about that. A machine built in the 1970s, still communicating across interstellar space, almost a full day away at light speed. At some point, probably within the next decade, we'll most likely lose contact forever. Not because Voyager stops existing, obviously, but because its signal becomes too weak for us to hear. And then Voyager will just keep going, silently, for millions of years, and never stop. And that's part of the mind-blowingness about space, of course. Anyway, Voyager 1 is now closer to other stars than it is to the center of our solar system's influence. And one day, long after Earth is gone, it could still be out there, carrying a record of humanity. So, here's the question. If another civilization eventually finds Voyager, do you think they'll understand what we left behind? Or will it just look like meaningless noise drifting through space? Thanks for watching, guys, and keep expanding your universe. See you next time.
Don't forget to like and subscribe. It's free, and you can change your mind at any point in time, and it really helps me out as well.